We mentioned in the previous video that if we can use package managers for installing things, they nicely take care of all the steps for us. However, we cannot always use a package manager. Sometimes we don't have the root privileges for our system, or sometimes a software that we may want to install may not provide us with packages suitable to be used by apt-get, brew, or pip. It is indeed up to the authors of the software to provide such packages that can be installed via such package managers, which many authors do these days, but it is not to be taken for granted. Older software, especially, may require your manual installation. Such software is generally downloaded as an archive file in tar, gc, or zip formats. So if you cannot find apt-get or brew or pip instructions in a software that you are interested in, and you find out that you have been provided with only an archive file, chances are you will need to do a manual installation. Such software is generally C-based, since Python packages are installed by pip, so you would have typically been given pip instructions, and Java software is distributed as jars that can be run on any machine that has a Java virtual machine. However, C code is more problematic. C is different from languages like Python in that it doesn't have an interpreter. C code must be converted to a machine executable by a process we called compilation. We used a software called compiler for this. This makes running C executables super fast, since all the necessary preparations for running it has already been carried out in the compilation step. However, this compilation step must be carried out separately each time you carry your C software to a new computer. This is because C executables are machine dependent, and they already should contain all the low-level instructions specific to your architecture. So you cannot just download an executable from the internet and expect that it runs on your system. Instead, you must download the source code for it and compile it again so that specific executables that can work on your system is produced, and only then you can install these executables. Another note you should know about is that compilation stage the standard mechanism for such manual installation uses some tools to make it easier for us. This is in general known as the configure, make, and make install pipeline. So, something like this. It consists of three commands, starting with the configure command, then the make command, then the make install command. We will see one by one what each command does. They basically translate to preparing for the compilation itself, and distributing to the files to findable positions in your computer. First, let's talk about the compilation step in general. The C compilers in our system are the most famous C compilers really are GCC for compiling C files is the GNU C compiler, and G++ for compiling C++ files. This is a more advanced version of GCC that was issued later. So, say we have a simple C file, a C code like this. You will see here, for example, a reference to using the standard C input-output library. So this is a usage of a library in our code, and this code will require that this library is already installed our system. So let's say this is our C code. To be able to run this code, what we need to do is compile it using the GCC compiler. So this is the basic usage of it, and this is going to create an executable file called a.out by default. If you like, we can rename this a.out file by forcing the GCC use this name for the output. So let's compile it again, for example. Now we can run this executable, which has been compiled for us, and it will ask for some information and then give me some kind of output. So very basically, this line is how we compile a C code. If we had a C++ code, for example this one, so this code is written in the syntax of C++. Again, there are three libraries, so these are calls to some standard libraries that can be used in C++, and then when we try to compile this, we cannot use GCC anymore. GCC cannot compile C++ files, so we will get an error. We need to use the correct compiler, which is going to produce us the a.out, and again I can rename it using the -o option. Something to keep in mind is also the G++ is able to compile regular C files as well, so you don't really need to alternate between GCC and G++. If you're writing both C and C++ code, I think you can just go and directly use G++. Anyway, so we have compiled our C++ code here, and we can run it like this, and this is going to give us some kind of information. Now, the thing that you should keep in mind is that by compiling these codes with the compiler, we have only created the machine executable files, but we didn't actually install them. To install them, we need to place these executable files into places that the system is able to find them. So this can be either system level files, such as the USR local bin, or we can, for example, copy them into the bin folder that we have created and added to our path variable. So if we go and copy these files, for example date, the date executable, to our bin folder, then we will be able to run it. Okay, it's yeah, it's coinciding with the date utility that's already in Linux and probably is in one of these directories. So this one is already run before it comes to mind. I will give it a second name, and then I will copy it to my bin again. Yes, so this is my date. So now I can run it without any dot and slash at the beginning, and this is because I have installed it. Well, this was a local installation to my home directory. If I were to copy my date to USR local bin or some kind of system folder, then this would be a system level installation. So this is kind of easy for a program that we have created ourselves. The program consisted of a single source file, date.cpp or pascal.c, and it was rather straightforward to compile them using only one GCC command, and it was also really straightforward to install them using one copy command on a single file. So this is really great if I'm doing my own coding and my own compilation, basically. However, typically the software that you want to install from the web is much more complex. It is going to include multiple executable files, libraries, and maybe headers. We even may not know exactly what kind of steps to follow to compile it. The exact steps to compile it, the libraries to use, and the places to put them in the system, it can change from system to system. In this case, the authors of the software typically provides us with a makefile. This is a regular text file called either makefile or sometimes with a small m, like this, makefile, that describes the steps that one must take to be able to compile this code. There is a utility in command line called make. This exists on virtually all Unix systems. The make utility follows the commands in the makefile and carries them out. You will see more about make and makefiles in the forthcoming videos. You can, for example, write your own makefiles if you want to produce a big project that is composed of multiple components. So each time you don't have to remember in which case to compile and prepare it. If the compilation process is rather simple and the software doesn't depend on a lot of fancy libraries, so the authors expect that the installation will be more or less the same on every system that people may want to run it, then they can directly provide us with a makefile in their source package. So let's see one simple case. If you can search for this script, evalb, so this is a script that is used in the Pantry Bank evaluation. So this is a script that's used for constituent parsing evaluation over Pantry Bank. And when we check the contents of this folder, there is one C code here. And the authors provide us with a makefile. And this makefile contains 2 lines. You are going to see more about how these lines are structured in the next video. But basically it tells us that we need to use this kind of command, so the GCC compiler, and name our output evalb with using these kind of options in the GCC. So this describes us basically how we are going to compile our code. The makefile is the make utility is going to go over these commands and process them accordingly to perform the compilation. Generally, makefile is necessary for more complex cases than this, in which the sequence of creating the executables can be important, and now we are going to see another case that's related to this. So, let's say you are shipping a complex software that depends on a lot of settings. A makefile in that case cannot be given to you as this, so the author of the software may not know in advance what kind of settings are existent in your system. In such a case, a makefile really needs to be hand-tailored to your particular system. In that case, the software is not going to include a makefile by itself, but it is going to include a bash script called configure, which is going to create a makefile specific for your system. Let's now see such a case. We can try to install the ImageMagick that we have installed using the package managers in the previous video, so that we can compare and contrast how the different cases are. So you can go and download So you can go and download the source from the ImageMagick downloads website. When we are checking the downloads website, there are a couple of nodes that you will need to be searching some kind of keywords. So this line, you can install ImageMagick from source. This means that using this package, we are going to do a manual installation. These binary releases are prepared packages for Unix systems here. So for example, the RPM is a package that can be used by the Red Hat Linux distributions package manager. So you cannot use these files on your Ubuntu system. You must need an RPM package manager for this. So let's see what else there are. There are some yes, so this seems a binary release for Mac OS. Port is also a package manager that can be used by Mac OS. And well, we have seen that ImageMagick already supports the package manager. So they already give us some options to install via package managers. And for example, installing via Brew manager is also possible, and these are instructions for installing with the port manager. So there are really many options for ImageMagick. They even have a release for Windows. You really don't need to compile this from source, but we are going to try to see how it works. So let's go to this tab of installing ImageMagick from source. So this tells me to, in Unix, to download this targz, or I could have used the wget for it. Let's do that one. So yes, we have now acquired a targz file. As I noted before, the targz archive file is generally meaning that you must do some kind of manual compilation. So let's open it. This created this folder. And now we are seeing the contents of this file. So the first thing when you open such a folder is to check the readme.txt, and if there are, then to check the relevant installation directives. Always read the readme file. It doesn't have to be a .txt, it can only be a readme, and always read any other notes related to installation in case there is something relevant in it. If we don't have any readme and if we don't have any installation directives, then the classic procedure is to do the configure, make install pipeline, but we never know before really reading this file. So let's check what these guys have. This is an introduction, and it talks about what ImageMagick is, some features and capabilities. There are some news and nothing else here. So this kind of also gives us a hint. So if we want to reduce the quality of image results to save memory, for example, I understand if you don't have a lot of memory, if you don't have good performance, then we can use these configure script options. This is a hint, for example. So we can keep this in mind. But in general, it's useful information to know. So now I have checked the readme.txt. Now I'm going to check the installation guidelines. Software doesn't always have to provide you these installed -unix kind of files. Things can be written in just a readme, but here they have us different installation guides for different systems. I will check the Unix system first. So it tells me to download and unpack ImageMagick, which we have done. We have unpacked with tar. Then it tells me to run the configure script. We will see about configure script in a bit. This is a bash script which is going to prepare the make file for our system. It tells us to watch the configure script output to verify that it finds everything that it should. This is an important feature of the configure script. While preparing the make file, it checks if it finds all the libraries that it needs in our system. If it finds the library, it notes their location for makefile so that makefile can reach them easily. If it misses some kind of crucial library that the software cannot be built without, then it's going to give us an error. In that case, so this is how the manual installation is problematic. So if configure keeps giving us errors, I can't find this dependency, I can't find this library, then you must stop everything you are doing and then go and install that library. And after that you try configure again. And sometimes configure looks for some kind of an optional library. For example, it's going to give another feature to the software that you are running. In that case, configure may complete successfully, but it can give you a warning. And in that case, I think it's important that you check the warnings. For example, maybe you are going to need that specific function of the software, and then you may want to go and install that library and then run configure again, so that the software is also including that kind of optional feature that you are going to need. So this is some information related to the configuration options. This prefix is an important one. We are going to talk about this later. The prefix is basically how you can set up this manual installation to be in a system level or in a local user level. So prefix denotes the installation location. In the default case, it's going to make a system level installation and it's going to require sudo permissions from us. However, we can as well change this prefix during the configure step, and we can configure it to be a local installation. First, I will continue with the global installation, the system level installation, because that's the default case. And then I will redo all these steps that we can also see a local installation. There are all kinds of settings here. For example, in configure, you can also change your compiler and you can give other flags to your compiler and all kinds of things. So you can look at this in more detail if you ever need. So this gives me some information about the configure still. These are all kinds of flags. So when I'm configuring, I can say that, for example, build my software so that I don't want any PNG support, so that I don't want any TFF support. These are done by giving these flags to the configure script. We are going to see this in a bit. This is also giving me hints. So common cases of configure failure can be this and this and this. These are nice in general that the authors are giving this kind of hints to us, but in case of a configure failure, the first thing I would do would be generally a Google search by the error. So now that if you have configured ImageMagick, it says now we are ready to build. Build means internal compile. So using the command make after a successful configure is going to, it's going to build ImageMagick. That says, well, it's going to compile the source and it's going to create the executables that can be used. There is another command that is make install. This will require a sudo before it, and this is going to install ImageMagick. This means it's going to place the executable files and all sorts of libraries and things to the findable locations, and this will be our third step. There are other things, other useful commands. Make check is used for running tests if everything is running correctly. We can also try this, for example. Make clean means remove the compiled files. So make is going to run again the next time. You will see more about these things in the following videos. So, and there is more kind of um, instructions. Well, the instruction that this told us was pretty standard. So it tells me to configure, it tells me to make, and it tells me to make install. But it could have included some dependencies that I should do first. I think the Mac case installed this. So let's now check the Mac installation notes. This is okay. It tells us that we will first need Apple's Xcode. So for this case, it's important to check this installation notes. We have actually installed this Xcode when we were trying to install wget in our Macs. So this step we can skip. What else does it tell us? Well, it reminds us using Homebrew is really easy. So we can just install with this. For the very simplest, fastest, most basic installation, just run this. And we have done that. But here it's nice that they remind us again that there was an easy way of doing this. I'm skipping this now because we want to compile from source, and this reminds us that we don't need to do this if we have used the Homebrew method. Well, this is the alternative installation, and now I'm going to do this. Okay, it needs some these kind of additional libraries. So if I'm doing an installation from scratch, I would copy each of these lines to my bash, and I would run each of these steps. Now I want to save time in this video. These dependencies were already installed in my system by Brew when I was carrying out this step. So now I'm going to pass them for the sake of saving time. But I still wanted to show this file so that you have an idea that before you can start with configuring, it's a good idea to check the dependencies, because if configure can't find these libraries, then it's going to generate an error anyway, and then you will need to go and install these libraries. So you may as well in advance check what kind of dependencies are required and carry these on. But in our case, since we have already done the Homebrew option, these libraries are already installed, so I don't need to install again. Then it tells me if the dependencies are complete. Now let's build ImageMagick. Download the source distribution we did. We unpacked it. We went into the folder. Now we are going to configure. This gives us some configurations. Now this uses this opt directory as default in the Mac case. It's possible this is the author's option for using this kind of installation directory because we are working in Mac. It's possible you can use it, or you can still configure in the default directory. This gives us some kind of other options, for example without Perl. I'm going to use the recommended options here, so I can as well use them. Let's go here, let's check the contents again, and now let's use this configure script and see what it is doing. So this is basically a second line. This backslash allows us to go to a second line to continue with the same command into different lines. This doesn't matter, by the way. There can be all sorts of white spaces here. So let's see what the configure is trying to do. I will go slowly. The configure is checking everything in the system. So checking the build system type. This is my system. Is it a BSD compatible install? Is the building environment sane? This means can I find necessary compilers and everything. Do I have Gawk in my system? No. Do I have Mawk in my system? No. Do I have Nawk? No. Do I have Awk? Yes. So it's going to use Awk. It was checking for Awk substitutes basically. So the first Awk it finds, it say, okay, yes, I'm going to use this. So what else, for example, is important? It looked for GCC, it found it. it checked if it's working. Yes, it's working. C compiler's default output name was a.out. So if it gives no name to the outputs, it will be named a.out. What is the suffix of executables in our system? It is none, because I'm working on a Unix system. So if I was working on a Windows, this is with .exe, exe. Basically, suffix of object files is this. What else? GCC accept this flag. So you can see it's making all sorts of checks. Sometimes it's looking for some kind of optional tool. So I don't have this one, I don't have this one, I don't have this one, then I'm going to use this one because this exists. So it can be checking multiple things. It can be checking for some libraries. What else? It looked for the linker that's used. What else is relevant? For example, are we using the Microsoft C compiler? No. Is there a Windows.h? This means I'm on a Windows system. No. So you can see this configure thinks that it can also be running on a Windows system. So it's checking, is this a Unix system, is this a Windows system, what kind of compiler is used in the system, and Makefile is going to be prepared with all these information in it. That's why I need to run this configure. It checked all sorts of things, like my data structure. So what is the size of unsigned long in this system? Yeah, all sorts of stuff. So it gathered basically information about my system, and I think it has exited successfully. Let's see here already that I don't see any errors. It did run successfully, and is presenting us some kind of an output, a summary of its findings. So these are what it found. I think, for example, like these are the values that it assigned to these options. So shared libraries will be enabled, static libraries will be enabled. You don't need to understand what all of these are, but in general, if you understand what this is, then it's good, I think. It's used these options for compiling, so it's using the prefix that we have given to it as an argument. The installation will be made under this root opt folder. These are the C flags to be used with the compiler, and so on and so forth. So let's check now. We have by this moment a Makefile in our system, and let's check the contents. So this is generated automatically. This Makefile will be very difficult to understand. Configure checked for all sorts of things. So as you can see, this is a really complicated Makefile as opposed to the one line, two line Makefiles that we have seen. But for example, this line, I think it shows how to make some kind of dependencies. So how to compile all these C sources and their headers together. In general, it's very difficult to understand this kind of automatically generated Makefile. You will see how you can write a Makefile in your system in the forthcoming video. But basically, I think it's what you should understand is this is a directive for creating this dependency, and then this dependency, it's like an environment variable. So this is like an this is the instructions that you must carry on to create this dependency, and then you are going to use this dependency in another place like a variable. Yeah, so we can exit now. The important thing is that configure run successfully, and we have created our Makefile. Now we are going to compile the source, and we do this using the make command. This is going to run the Makefile for us. Okay. I wonder, make generally takes longer. I think I have prepared already. I have already made this folder before this video, so it ran out very quickly. I will clean first. Yes, all these sources were prepared by my previous running of make. Now I have deleted them. You see all of these things are deleted by my make clean. and then I'm going to make again. Now it's going to take more because now it's actually building everything from scratch. You will see more about this. So if I have already built before and prepared some of the object files, make just reuses them. It doesn't go and do all the compilation again. So make is actually very time efficient. Mika is going to tell more about this, but if I want the system to compile everything again from scratch, then I need to give the command make clean. So in the make file, let's check this. There are some directives. For example, the clean directive. I will try to find it. This one. So this command is run when I say make clean from my command line. This is one of the options of running this make, and this runs this clean -am command, which is here. So it runs all these flavors of cleaning. I think this, for example, this cleans the binary files. One of these definitely cleans these libraries. This cleans these filters, whatever it is. So these are different commands. This option, this command is requiring this to be done, and this requires all these to be done, and all of these go and remove some compiled files from our system so that the make can run again. Install is also one of these flags. So there are different kinds of install again here, all sorts of install directives. Okay, so this lines is what runs when we say make install. So this is the install option of make, and this requires all these commands to be run. This one is going to be run, this one is going to be run, this one is going to be run, and then this is going to be run, and this option is here, and it is going to run this option. So you can see how make is describing what to do in every option case. The most clear ones are the most commonly used options like this are install, clean, and test, and I think these are the ones that you should know. And these more fancy ones are generally internally used, so you don't ever call make with make install data am, but you just say make install and it takes care of all the rest here. Yeah, the make is still compiling, so you can see what kind of complex software this is. A lot of libraries are being compiled. I think it's going to take some more time. Yes, now it's done. Now let's see what ls is giving us. And for example, what is in this magic core. Okay, these are the source files. There are some libraries here that were compiled. What about these utilities, for example? What does it have? Utilities, for example, installs this executable. And what else? Yeah, there is this object files for this and temporary object files properly. What else does it have? For example, what is there in this magic plus plus? Okay, so these are the files that I was looking for. There's a bin folder here, and there is a lib folder. Okay, these libraries have been compiled, and this is, looks like another folder. Yes, so another folder. So you can see the insides of this folder is really complicated. There are source files everywhere, there are executables. The authors have some kind of sense for organizing these folders, but we don't really need to know. It's in general difficult for us to know so which binary is coming from which file, which library is there. So it's really difficult for us now to go and install things by copying with our hands. That's why we use make install, because make install now knows where every file is, and it's going to take every necessary file and place it to uh, known locations in our system. Make install is going to require sudo in the system level installation case. This was already mentioned in the instructions file, if you remember. So make install is by general typically is always used with sudo unless you have configured to do a local installation. So let's try this. This is going to ask for my password, my user password, and I have given. Make install is typically much more faster than make. What it's doing is basically is just copying the files around and making some settings for this. Yeah. So after I run make install, my installation is complete. If you didn't receive any errors during configure and make, likely you won't receive any errors during make install as well, and we have successfully compiled the and we have successfully carried out the system level compilation. Now, if we don't have the root permissions and if we want to do a local installation, we have been telling about this for some time now. So we will need to use this configure command again. Then I'm going to configure from scratch. First, let me do a make clean. Anyways, to remove the, well, this is not necessary because I'm going to change the make file now, but anyway, it's good practice to get used to doing make clean. And then now I'm going to change the installation folder for this software. Now I'm going to put it under Chilikan. For example, here I have a local folder, I think. Yes. And I want to install under this local folder. So like this, I'm giving it a new installation directory that is under my home. And this is going to make all the difference. The configure is doing all the checks again. Yeah. Now you can see that the prefix has been changed, the installation place have been changed. Now I'm going to do a make to compile. and the compilation is complete. So now I'm going to run make install to distribute the files, but this time I don't need the sudo anymore because I'm in any way using an area that's under my home directory. You see that the installation place has changed now. It's under my home here. So let's see what happened to that directory. For example, under bin, now I have this executable file, and under lib, what do I have? I have this ImageMagick libraries, and under include, maybe there are some headers, but let's see. Yes, under include there is this folder, and under it will be the headers. So our installation is not yet complete. We have one more important thing to do. Let's copy this path and let's open our bash rc. Now we must add this path to the findable paths in bash rc so that these files that have been distributed by ImageMagick are discoverable. So first I will start with adding the binary location to the path variable. So path looks for binaries, and my binaries were under this directory and under bin, so I'm going to add the bin directory here. To the library path, I should add the path of the libraries, which is going to be lib. I need to add one more library path here. That's because he makes a distinction between dynamic libraries, that is shown by the LD library path variable, and static libraries that are shown by the library path variable. In general, the libraries that end with an .a extension are static. Let's see if I have any such static libraries here. I'm not sure. It can be all dynamic. Okay, so this is a static library, and the path for this one needs to be in this variable. And any dynamic libraries, I believe these may be also examples of dynamic libraries. In general, .so and .lo are dynamic libraries, so if there was anything here that ended with one of those extensions, they would also be required to put under this one. In general, I recommend you can duplicate this information. It's completely okay that there is here more paths in general. So I will use this path in edit into both of these variables. You can check more into this if you are ever doing some kind of C programming by yourself. And finally, I'm going to put a C plus include path. This is if in general I want to develop any kind of code that includes that needs the ImageMagick libraries. I don't plan to, but this is good practice to put in general. So I will first take the existing value of the variable, and then I'm going to add the include path. So once done this and done this, and now I'm complete. Now my installation is complete because now also system has the information of how to find these locally installed files. So this was a bit of a complicated video. As the time passes, more and more software provides us with some kind of packages that can be used with package manager. So hopefully you won't need to do this kind of compilation yourselves. But in general, it's good to know at least the basic pipeline so that you can have a sense of what's going on. So see you in the next videos for creating some useful make files that you can use by yourselves.